Alright folks, today we're going to learn how to solve a polynomial, and we're going to do that by factoring and using the zero product property. Here's the initial problem. Let's go ahead and first let's get things in the proper order. So we'll do x to the fifth minus 13x cubed plus 36x equals 0. If we want to solve a polynomial, we got to get everything equal to 0. Then we can use the zero product property. So next thing we'll do is we'll factor out the GCF. This is huge and you should make a note of it. Whenever you're factoring a polynomial, always factor out the GCF first. Always. Factor the GCF first. So let's do it. So we take out, in this case, just x, and we get x times x to the fourth minus 13x squared plus 36, and that equals 0. Now, in this case, we're not done factoring. We still have more to go. What we'd like to do is we'd like to also factor this part here. So we're gonna do what's called factor completely. We still need to factor more, and the way we'll do this is we're gonna use the good old faithful x factor method. We'll put negative 13 down below, and then 36 up above. Now some of you might be freaking out because we've got this x to the fourth and x squared, but don't worry, we'll get to that in a minute. And then we make a list of all the factors of 36, all the factor pairs. And that includes 1 and 36, and 2 and 18, and 3 and 12. And none of those seem to get us 13. Oh, hey, I forgot, 4 and 9. That's one reason why it's worthwhile to make a list of all the factor pairs, because there might be one that you forgot about. So we put 4 and 9 here. We'll do negative 4 and negative 9, they add up to negative 13, and then negative 4 times negative 9 gets us positive 36. Now, the next part is a little tricky. I'm going to have to, let's see if I can do this. Oh, that's right, I forgot I could do this. Let's go ahead and write out the factors now. Now, what we'll do is this. Just like we have in the past, we will write x, and we'll do minus 4, and then times x minus 9. And don't forget it's still equal to 0, and we still have this guy here, that x out in front, so we've got to keep that. Now you'll notice if you try to FOIL x minus 4, if you try to FOIL this guy times this guy, you're not going to get this. It just doesn't happen. So there's something that we've got to do, and what we'll do is we'll make this x squared and we'll make this x squared. Now, this only works when this middle exponent is exactly half of this exponent. So it doesn't work all the time, it only works in this case. So we're getting pretty close to solving this polynomial. The only thing is that we didn't finish factoring completely. So let's go ahead and do it. Here's x times, don't forget x squared minus 4. X squared minus 4 is known as a difference of two squares, and x squared minus 9 is as well. So we'll go ahead and make x squared minus 4 into x plus 2 times x minus 2. And we'll make x squared minus 9 into x plus 3 times x minus 3. And that's all equal to 0. Now it becomes pretty easy to go ahead and factor all these guys, and to take all these factors. We can take this as a factor, and this as a factor, and this, and this, and this. Since we're multiplying them all together and they equal 0, that means that either this is 0, or this is 0, or this is 0, or this, or this. So let's go ahead and see what happens here. If we say x is 0, well, then x equals 0. If we say x plus 2 equals 0, then we can say x must equal negative 2. And for this next guy, if x minus 2 equals 0, then x could equal 2. And for this guy, x could equal negative 3. And finally, for this last guy, x could equal positive 3. So it turns out for this polynomial, what we get is the possible solutions include 0, negative 2, positive 2, and negative 3, and positive 3. Now I want you to notice something interesting about these guys. What we have, the solutions here, the number of them is what's interesting. We've got 1, 2, 3, 4, 5 solutions. And let's go back and take a look at our original polynomial for a second. So if you take a look at our original polynomial, this is it right here, you'll notice x to the 5th, it's a 5th degree polynomial. And that's kind of an important fact here. Since this guy is a 5th degree polynomial, what it means, 5th degree, what that means is that there could be as many as 5 solutions. So up to 5, let's actually say 5 real roots. Now there could be less than 5 real roots, and there could be some imaginary roots as well, some complex roots. The total number of roots will be 5, but there can be up to 5 real roots. In this case, we've got 1, 2, 3, 4, 5 real roots, and it's no coincidence because we have a 5th degree polynomial. That's important. It turns out that that is a rule that we can use for other degree polynomials. And that's it. That's how we solve that polynomial. There was a lot of factoring, and there was the zero product property, and that was that.